All right, so hello, my name's Allistair, CTO at Coconut, and I've been asked to, I came up with the concept of giving you a presentation on the journey that Coconut have gone through over the last year and a half, which will be a technology journey and reflecting on some of the choices that we made, why we made them, whether we'd do some things differently. Our mission is to free the world's self-employed and business owners from accounting and administration, because that's really painful for people, and we find that a lot of our customers are using six plus tools to manage their working lives, and we have built Coconut to bring that all together into a single place. So we do that by offering a UK current account and a MasterCard, like a lot of fintechs that you see. But we add value on top of that through the rich data that we receive from those activities. So, like Monzo, a lot of people will know. So transactions, adding receipts, so doing faster payments. But we've also added recently invoicing, so you can invoice people and have it auto matched to when payments come in. But we also try and do a decent tax estimate as well. People really struggle with tax. And most recently delivered VAT recording, which is a HMRC requirement going forward. So that's what it looks like. Won't dwell on that too long. Transactions, we've got invoicing there. This is the newer VAT feature, and then an illustration of a tax estimate. And also, if you've got an accountant, they'll thank you for Coconut doing the bookkeeping. You can share your data with your accountant, and they can go into a web portal and do all the value add that accountants ultimately do. So going back to May 2017, I met the founders, Sam and Adam, and the job spec was basically to design, build, and operate this thing, Coconut, get it to market by January 2018, and operate as a CTO, startup CTO. And at first, like, that's super exciting. A lot of greenfield, make any choice you want in the world, like, it's perfect. But very soon you realize you're working in fintech, a regulated environment. I've been in previous startups where you get things wrong and, like, customers just go mental. And this was to do with money, so I started getting a lot of anxiety, pretty much like the last week, and lots of decisions to make. So the following steps are sort of how I moved through that process. So we've some players like Monzo and Starling are regulated banks. We chose not to go down that particular route, which takes the sting out of the tail a little bit. So we've partnered with a sort of banking as a service partner, and they worry about sort of connecting to card issuers and, like, clearing houses and all the rest of what goes on in the payment cloud of mystery, as we call it. And we can just, via a sort of XML SOAP integration, sort of add a lot of the value features on top of that. I'm by no means, by the way, like an ops sysadmin guy, but I have done a lot in the past, just out of necessity, and I'm quite familiar with the space. So I knew I had to look at sort of different types of workloads involved. So onboarding, for instance, when you look at how you onboard a customer in this space, you know your customer, sort of legal obligations, who are they, and you have to have decision making, and you can't just do that in a synchronous way. So we need asynchronous processing was sort of one thing coming out of that. And then you've got things like computing tax, like how hard is that? How hard is the math? Is that going to sort of tax all of our CPUs and whatnot? So looked at some of these workloads to see what we needed. Looked at the data. So the big question in this sort of space is relational or NoSQL. And as you see from the names here, this is really what sits in our model layer, and it's just super relational when you look at it. And this one's got one of those, it's got many of those. I didn't really see a strong need for NoSQL land, but one of the choices we made later would sort of provide, in the database, would provide us a way of having sort of unstructured data as part of our row sets. It's quite nice. Step 4, so I've been a technical architect before in an agency, so all the illities of a system, sort of documented these, like Is it going to pass muster when I run this through penetration tests? Am I going to be able to... you start off not knowing whether anything you're building is going to be used by anybody, so that what scaling do I really need from the very start? Can I hire people out there? I came from a Java background at the beginning. Do I use Java so I can hire people? There's loads of people. Yeah, so all of these things you think about, and it was really hard to ignore microservices back in 20. I don't mean to diminish microservices at all with this. Someone said I was. I'm not. It's just back when I was doing this research. This was. A lot of people were talking about this, and I went in some kind of crisis. Should I be doing microservices? But having read a bit about it, about how it solves problems for different product teams and where you want to deliver features at different paces and so on, and I was like, I'm by myself. I've got 6 months. I need to build a bank. Well, not a bank. I need to build Coconut. I don't have time to invest in this. But it's super exciting. The last stage was, so what language am I going to use, which frameworks, tools, and obviously you guys all know this stuff. So I found it really helpful just to write down, and I wrote a little technical strategy document for the co-founders, the guiding principles that would sort of defend the decision that we went with in the end. So I was really keen to choose tools that were really battle tested, been out there for a long time. That minimizes the risk in terms of the tooling and what can go wrong there. Because I would be the only developer for a long while and operating this, I wanted really great testing support to sort of act as another developer, if you like, and keep me on track. And then just keep things simple, repeatable, because we'd need like different environments, and you would like test the UAT production environment. So repeatability is going to accelerate me in creating those environments, and be able to deal with this stuff myself was really the main driving factor there. I had to deliver the infrastructure, the components, which were the mobile API, customer portal. People are going to start talking to you when you deliver a customer-facing service, and people are going to want tools to deal with them and change their data and make things right. And then some of the banking partner feed processing around transactions would need to be dealt with, and then I would hire a separate mobile team to help with that. Some quick tips of making hard choices that I found useful. So the guiding principles, really handy to think about what your decision is going to be governed by. I did try to keep a very open mind, and I tested a lot of the tools. So whilst I'm not, for instance, a Docker expert, and I wasn't then, I'm not now. I did try it out, and I tried a lot of the tools out before I did the Kubernetes sort of Google trial and tutorial, just to see whether it felt like something we should use. But ultimately, settled on something where I felt comfortable, and just realized and got comfortable with that. There is no one best option in this space. There are just so many things you can bring together, many ways to roam, and off we went. So July to launch. We chose fairly predictably Python, Django, and Postgres combination. So one of the massive features that I did not want to build in the 6 months was the customer administration tool. And Django really delivers an outstanding automatic administration platform and hooks to do customizations. And that was really standout for me. And it's a really mature, well-tested, considered highly secure, great permissioning framework. And it was really delivering on a lot of fronts that I cared about. It's generally partnered with Postgres, but Postgres also has a really great data type called JSONB, which would handle some of the... I wanted to store some of the metadata that came from the banking partner on transaction rows, just in case I needed them later. And this JSONB data type is just fantastic for doing that. Python, obviously, very, very good general purpose library, and some of the stuff we wanted to do in the future, such as enriching transactions, categorizing them, assigning them. Is it Sainsbury's 1829 store, like you would see in your general banking provider, or is it just Sainsbury's apostrophe, nice logo? So that some of that would require machine learning tools in future, and Python has a good support for that. Just a quick side note on the JSONB. So you can store JSON just like this and select it as if it was SQL. And there's various comparator operators that you can use to drill into nested structures and grab values out of a JSON thing without needing to be NoSQL necessarily. And this has been really handy for customer support. They'll come and say, well, actually, we need to see the method by which a card transaction was accepted. Without needing to add a new column, I can just go into the metadata here as a sort of a stopgap. Celery, so the async workloads are really important. We do lots of sending emails, reacting to real-time events when people spend on their card, sending push notifications, and lots more besides. And Celery is a super mature library that works hand in hand with Django and Python, and you can literally just run your same code base on a different server cluster. And just the handover between your app servers and your worker servers just with a line of invocation. And it's got some really, really nice stuff that we found, like intercom would be down quite often. And you can just annotate with decorators on your functions that I want to retry this with exponential backoff, or if this particular exception happens within the background task, then I want you to invoke it five more times. It's a really awesome tool. And you just plug that into a broker, something that's going to remember what's been asked of the Celery cluster, and it'll save that reliably and make sure it gets done. So everyone's going to look at that thinking, where's Docker? So it's really just about what I knew at the time. So I came from a place before, and it just helped me get really fast into developing Coconut by using Vagrant. I mean, Vagrant does a lot of the stuff Docker's doing. Obviously, it's not quite as great, but it also aligned with the decision that I made on the infrastructure, which was to host with dedicated EC2 servers in the first instance. You've got to think about things like your budget, your runway with a startup. Like, how much do you want to invest in something if you don't know it's going to work? So this aligned quite nicely with those decisions, which were these. So. Most of you, I think a lot of you will understand this. So we have sort of app server, worker servers running. So app servers running Django API, worker servers running Celery. We've got Elasticache in the middle to broker. Lots of KMS to encrypt databases and secrets. We've got Postgres running an RDS. I didn't want the headache of managing that on the server, so use managed servers. And then obviously S3 CloudFront for files. The receipts that you take with your transactions, all nicely encrypted in S3, and when people view them in the app, we use URL signing, so cookie signing now actually, to give them a period of time they can view them. They're nice and secure. And actually we did use Lambda and plus SQS. You can call it a microservice if you like. It ingests the batch files that we get from the banking partner periodically. They come every 2 hours and gets them into our database. And on top of that, why not add guard duty? I didn't have a DevOps or Ops sysadmin to look at how much we were being prodded. CloudWatch was great just to see how the servers were coping, obviously. CloudTrail, regulated environment, configuration management, and Sentry for just exposing anything that was going wrong in the code. Yeah, you can see that. So that's a high-level network. This is a pattern basically created off of the AWS blueprints, the Bastion blueprint plus web scale blueprint, pretty typical. Choose a region, multi-AZs, public, private subnet, NAT gateways, and then you have everything inside the private subnet, and then Bastion host to enter into it. And then we've got some of the shared services around the outside. So all of this was terraformed with modules. I did a bit of Terraform before, and the repeatability point I was talking about before, needing this to be a new AT and live, and there's so much going on, I couldn't just point and click and set this stuff up. So decided on some infrastructure as code. This is just a snippet, there's a lot more besides, but you can see if you group your Terraform into modules like database, S3, the VPC, and so on. Your UAT and live can just plug in variables into those modules to say, well, in production, I'd like an extra large T3, and sort of in UAT, it's less important, I'll take a small. So you can just sort of plug all the differences between those two environments, but ultimately you stand up the same overall infrastructure. Just love Terraform, absolutely great. provisioning, deployment, again, just wanted to be repeatable with that. Ansible was a good choice for us. We were able just to stand up the EC2 servers with Terraform, get the IP outputs, and then just draw those into Ansible inventories, and then that would just provision. To show you this, maybe we've got the inventories for dev, live, test, UAT, and then all of the different roles that provision the, sort of Django, the cache, Bastion servers, and app servers, and so on. And we used Ansistrano. It's sort of like a Capistrano, if anyone knows about Capistrano. It's quite neat, actually. So you can choose from checkout from GitHub. You can use sort of deploy from a zip in S3 or just rsync. And it's really nice and fast. And you can just, I chose GitHub deploy until the penetration testing company said they didn't like it. So we moved away from that. Ansible was for provisioning deployment. A quick note on the serverless bit I spoke about. So when people spend money on their card, and they go into this sort of cloud, what happens is transactions settle over time, and that means that they're sort of locked in stone at that point. They're pending initially, and then they lock into stone eventually, and those are given to us as XML encrypted. GPG encrypted files on an SFTP server, not our choice. And so I didn't really want, I could have done this on Celery, but that would have been running sort of a mission critical ingestion routine on the app servers and work servers, and if I came along and introduced a bug in the code, I might bring this down. So I wanted this quite separate, and I was quite keen on looking at Lambda, and this is what I came up with. So we're just using CloudWatch on a scheduled cron sort of thing to call a Lambda. It downloads the file, adds it to S3. S3, it's got cool event triggers, use the object created trigger, kicks off another Lambda process, decrypts it with a key it knows about, also itself encrypted with KMS, and then it breaks it down into the individual JSON payloads, does a transform onto SQS. The act of putting the transaction onto SQS then triggers the ingest routine, which unfortunately goes into the API, and we're back in Python world to do the enrichment, like make the merchant name look nice, do the categorization, do the VAT. Maybe in future that would be quite nice to do in Lambda as well, but need not be. All right, how am I doing? 18 minutes. Okay, I'm going to have to absolutely storm through the rest of this. I've done too many slides. It's going well. We've got 11,000 customers. It's about 750,000 requests a day. I've got a team. James is somewhere in the audience here, my lead developer. We've launched a lot of features since. One of the things we've changed is Git flow. I love Git flow, but for various reasons, we wanted to get faster at deploying into production and feel more comfortable about very small releases, even stuff that wasn't finished. That made me very nervous. So we now feature flag all of our work as a matter of course, and we're trying to get comfortable with, you release a very small amount of work. It's good for code reviewing because things were so big, and it's good for product managers who want to keep shipping to customers and communicating that we're shipping stuff. And so long as you remember to feature flag all the unfinished stuff, you can sort of be happy, but tests. So we've since moved to the serverless framework for Lambda. Before, I used to get Ansible to log into a micro instance, compile the pip dependencies for the Lambda environment, and then download that, zip it, and I would drag it onto AWS. The serverless framework, if you don't know it, is just phenomenal. You can see here, just plugging in all the secrets, but crucially, we've got the functions, download, process, ingest that you saw earlier on, all the event configuration, and I can literally just do serverless deploy -- prod, and it just tears down your Lambda function, puts this one up, and it's just amazing. Not paid any money whatsoever on Lambda for 1.5 years. Do remember to set your memory and timeout to where it's needed. Look at your monitoring on Lambda, and add it to the right VPC so it can see your database and all the rest of it, and encrypt its secrets. Some tools we've added since then: Sentry, If you don't know it, it's amazing. Anything that's happening in Python land will give you a full stack trace that you can really hone in. You can assign it to people. You can see what the trend is. Like you can park it, and it will re-alert you. New Relic's great. Just wraps around the Python processes for both Celery and Gunicorn running app and worker servers. And we've been using Celery New Relic to really drill down into some of the places where stuff's a bit slow. So here, actually, I spotted this afternoon that we're doing 2 duplicate sets of user and customer queries, which are part of this 2.1 second slowdown. So maybe something to look at. So have really good monitoring. Circle CI used to run all this, run all the tests locally. It's a pain in the ass for the developers to remember that. Ground the laptop to a halt. Just added time and wasn't productive. So get Circle continuous integration working off of GitHub into something like Circle CI. I won't embarrass James, who added lots of fixtures and slowed down tests by 100%. Oh, I think I just did. Business intelligence, a lot of our devs were getting torn up with doing SQL for the CEO, who's really interested in what our growth numbers are and so on. Completely valid. Just get a read replica on your production database or some tables, do an ETL, and plug a business intelligence tool into that so that everyone can do their own SQL. Guard Duty, fantastic tool. Our bastions used to be on the public net. I'd be like, it'd be okay. But actually, hundreds and hundreds of port probes by Russia and China and Vietnam and God knows where really made me sit up and pay attention. So we've now secured our bastions quite tightly. So use that. So could just ask Tony, am I okay to continue for a little bit longer? Yeah. A little bit longer. Okay, reflection. So definitely overspec the infrastructure. So don't do that. The green-blue deployment seems to be something we need now. So it used to be I could deploy at 1 in the morning, but now obviously we have continuous usage over 24 hours. So we need to look at what we do there. Django's great, but you need to be very careful as a developer with these ORMs. Dot notation will just trigger lots and lots of new queries if you're not careful. Won't worry about the Celery thing. Find a good penetration test company. I've found a really great German company that do white box. They want to get inside your server and then actually, like, not just a lot of companies just offer like knocking at your door. They come inside the server and take a look around. And also they were really trying to hack the API and to understand the API, what it does. Like, can I see someone else's data by manipulating the URLs and that kind of stuff? Very valuable. Bad stuff absolutely happens. We've had a few bad things, but so make sure you've got some good support lines. So just very closing very soon. So current operations, I've now got DevOps. It's great. CTO doesn't need to do it anymore. So we're moving to a stricter server builds and looking at some scaling. Our stepping stone is going to be so we have a base AMI, we provision that with Packer and we roll that out to auto-scaling groups now. We're going to change to lower powered servers rather than just some big ones. Of course, when you add all these different servers, you still need to be able to monitor logs and search them and so on, rather than setting up an elk stack. We're using CloudWatch's agent on each of the servers, and there's a great AWS logs CLI tool that you can use to search across all of your logs. Good stepping stone. That's what that looks like. I'm sorry for the pace. Obviously getting TV dashboards up and running now. Now I've got someone who knows what they're doing in the office. All of our secrets, we're using AWS parameter store. I guess it's a bit like Vault, so our settings.py in Django used to read from the environment, but now it uses Boto 3 to connect into the parameter store, encrypted with key management service, and those get encrypted via an IAM role, so it trusts the fact that that's being asked for, gets decrypted, solves a lot of problems. And future ops, yes, we are looking at containers because they do have value for us certainly in the AMI build situation. Is about 15 minutes to get the AMI to roll out to the fleet, and we can get that down a lot more with Docker and manage our spend as well with using Docker and align all the environments to be a little bit more predictable than they are. If I was doing it again, instance sizes, I'd use reserved instances ahead of time. Be a bit more positive about existing in a year's time will save you about 50% of your costs. The worker fleet could have used spot instances to be more cost effective. Name things with date prefixes in S3 because it's a pain searching otherwise. Store money as actual decimals or not integers. Yeah, just organize Python into more modules. So I went crazy on the core module and then lots of services, but actually they should have been elevated. Yeah, so that's it. I'm sorry for the very quick talk, but I hope it's interesting. Thank you.